All right, in this lesson, we are going to take a look at direct variation some more. We're going to take a look at some real world examples. All right. So this example here says that you started a new part-time job at Discount Tire making $9 per hour. All right. This is a very straightforward example of how Y varies directly with X. Or we could say your amount of money you make varies directly with how many hours you work, okay? So for instance, again, let's go ahead and fill out our table here. Let's say we have our X and our Y. Let's just say you work 1 hour, you make $9. You work 2 hours, you make 18. If you work 10 hours, then you would make $90. And if you worked a 40-hour week, then you would make $360. Now, of course, in the real world, there are some taxes to pay and all of that. But based on this example, this is the money that you would make. All right. So let's go ahead and consider this real quick in a table. So if we were going to graph this real world situation, we could use the information from this table. Again, if we worked 1 hour, we would make $9. So then we could place our dot just below the $10, so right at 9. And then if we worked 2 hours, would be at 18, somewhere about right there. And if we worked, we have 10 hours on here, which would be 90, would be right up here. And of course, we're not able to put the 40-hour week. But what I do want you to see here is that with this direct variation, the graph would look something like this. And I didn't necessarily do a very good job of drawing that, but what you will see is that I want you to realize that it always goes through the origin. That simply means if you had worked 0 hours, then you would have earned 0 money. So anytime you have a relation or a function or real world situation that is direct variation where y equals kx, then your graph is always going to go through the origin right here at 0, 0. All right. This example says you weigh 6 times less on the moon than you do on Earth. All right, is this a direct variation? Okay, well, let's see. If it's a direct variation, then we need to be able to see how y varies directly with x. So let's fill out our table here. Again, we always have our x and our y. All right, if we plug in, let's say that we have someone that weighs 30 pounds on Earth. This example says that you weigh 6 times less on the moon than you do on the Earth. Now this is 6 times less. It doesn't mean you weigh 6 pounds less, but 6 times less. So that means we're going to find a sixth of 30. So what would you weigh if you were 30 pounds? Then you would weigh 30 divided by 6, which would be 5. Okay, so actually what we do have is we do have an equation, or we have a function that is in the form of y equals kx, and our y, our weight on the moon, is 1/6 of our weight on Earth. So we could say y equals 1/6 x, or it could look like this: y equals x divided by 6. So again, if we plug in, let's say 60, and we weighed a sixth of that, then we would weigh 10 pounds on the moon. All right. We could do one more. Let's go ahead and do 120. If you weighed 120 and then we divided that 120 divided by 6, then we would weigh 20 pounds. 20 pounds. Okay. And again, if we were to graph that, you would see that if you weighed 0 pounds on Earth, then you would weigh 0 pounds on the moon. That's because all direct variation goes through the origin on a graph, because 0 times anything is 0. All right. This is the last thing I want to take a look at here in this video. It says, does this following table represent a direct variation? Okay, so if we know that y equals kx represents direct variation, then what we also know is that y over k, or y divided by x, y divided by x equals k, all right? These two say the same thing, okay? All we've done here is we have divided this original by x. So over here on the left, you have y divided by x equals k, because these x canceled each other out, okay? But just know that we can also say that y divided by x equals k also represents direct variation. And we can use that when we're given a table like this to determine if this table represents a direct variation. In other words, let's put y over k, or y divided by k, for each one of these. So we have 36 divided by 12, and we have 45 divided by 15. We have 21 divided by 7. And we have 30 divided by 10. And you'll see in each one of these that they equal 3. Because 36 divided by 12 is 3. 45 divided by 15 is 3. 21 divided by 7 is 3, and 30 divided by 10 is also 3. Okay, so because y divided by x equals k, the constant rate of change for this example was 3. The k was 3. Every one of these fractions, y divided by x equals the constant rate of change of 3. All right.